Hi. In this project following the presentation in course 2 of the specialization, we will apply machine learning to identify fake news related to COVID-19. In this presentation, we'll first describe the problem we have selected, we'll identify the key tasks associated with the problem, and perform a basic task analysis. We'll then state our insights from the task analysis regarding how we might be able to simplify the task flow or improve the user experience with the task. We'll then go on to explain how the user will interact with our proposed solution, and we will describe our approach to each of the following key considerations of AI product user experience design, this being user inputs and any feedback loops, transparency of the model, and communicating uncertainty. We will follow by explaining any privacy-related concerns stemming from the data we collect and our use of the data in an AI system, as well as describe which privacy laws are applicable to our product and what obligations they create for us. We will finish by identifying the main potential sources of bias that we can anticipate, and we will explain how our product will meet the three goals of ethical AI, this being fairness, accountability, and transparency. Let's jump to describe our problem. Today, a great amount of information is continuously created and shared online, particularly in different social media platforms. Analyzing the information shared to correctly identify purposefully faked information and rumors has become a primary concern by many journalists and users, particularly with the outbreak of COVID-19, where misinformation can lead to actions that can be a risk for individual and public health. Facing this situation, this project will propose an accurate model to detect fake news regarding COVID-19. Our user Our typical user is a journalist professional and/or a social media user interested in staying informed of the latest news regarding COVID-19, and the key task is to identify a particular piece of information as containing possible fake information. So now let's review the user flow. The trigger for our user would be finding an article and being unsure whether the information is reliable. The objective is to inform whether the information may be a possible fake. For this, the user will use our product, Fake Checking, which is a fake news detector web plugin. The user opens the article and clicks the toolbar icon, opens Fake Checking, and clicks on the button that says Evaluate. Fake Checking then analyzes the information and responds by indicating whether the piece of information may be a potential fake. So, what insights can we take from this? Our model is already very simple in terms of actions required by the user, but we can include the option for the user to provide direct feedback to us in case he believes that the prediction of our model is incorrect, in order to improve the user experience and accountability, as well as to express agreement or to further improve the accuracy of our model. We can then open a new path in the user flow. The user decides to express agreement or disagreement with the model's prediction, and for this he uses the input field and action buttons in the same overlay where the prediction has been made, just below the prediction. This will allow us to retrain the model using the feedback provided by our users. So let's put it all together in order to describe how our users will interact with our model and further understand our user experience. Fake checking is a fake news detector web plugin. Whenever a user finds an article and is unsure whether the piece of information is a potential fake news, the user can click the toolbar icon, open Fake Checking, and click on the button that says Evaluate. Fake Checking then analyzes the information and responds by indicating whether the piece of information may be a potential fake. The user then has the option to express agreement or disagreement with the model's output prediction by clicking the action buttons below the prediction and add a comment in the input field, then clicking the action button Send Feedback so that the model can be retrained to improve its accuracy. Now let's review our approach to each of the following key considerations of AI product user experience design. Let's start with user input and feedback loops. Data is collected simply by taking the link of the page that the user is in. The user will click the Evaluate button for our product to start processing the text, and the system will show the output prediction together with a message asking the user to confirm if he agrees or not with the prediction, and giving him the possibility to give further feedback explaining why. Let's go on to speak further about the transparency of our model. Our model exists in the cloud, and it analyzes the text provided in a link and responds by indicating whether the piece of information may be a potential fake. As we have explained, if the user disagrees with the prediction of the model, he can express disagreement or disagreement in the input field and click Send Feedback so that the model can be retrained in order to improve its accuracy. The data collected will just consider the link to the article, whether the user has expressed agreement or disagreement, and if this is the case, the feedback expressed via the input field. This data is collected to continuously retrain and improve the model and can be corrected or deleted before being sent. Our model reaches its output by evaluating various factors such as the time of posting, specific terms and words, the author's name, and the source of the information provided, and it uses natural language processing techniques of bag of words and TF-IDF along with algorithms in order to process the information and express its output. We decided to proceed with this model based on the results of the training phase, measuring the accuracy scores and area under the curve of the model. Our model has limitations, such as the challenge to learn new terms and incorporate them, as well as the fact that misspellings or special symbols may interfere with an accurate information processing. It's always important in any case to communicate uncertainty, and we will do so by explaining to our user the percentage of our prediction being right, as well as the basis for this prediction. Now let's move on to the privacy considerations. We need data to train the models, but we shall collect only the minimum data to run them. We must ensure that we don't violate privacy laws to avoid legal actions and financial consequences, as well as to gain trust of users and attract new ones. In our case, we would like to reflect seriously on whether we want to collect any information of the users that can be linked to the feedback they have provided. On a first phase, however, this may put off users from openly expressing their opinion regarding the output prediction, so it is suggested not to do so if possible. Since our product will only be available in the European Union, we shall comply with the General Data Protection Regulation, or GDPR, and our main obligations will be, among others, to require prior consent from those we will collect the data from, to maintain a record of all categories of processing activities, including the details of the controllers and any other processors of any relevant data protection officers, the categories of processing carried out, details of any transfer to a third country, and a general description of the technical and organizational security measures. We must also implement the appropriate security measures, which might include encryption and pseudonymization, as well as requiring a regular testing on the effectiveness of these measures. We may only transfer personal data to a third country, in the absence of an adequacy decision, if the appropriate safeguards are implemented and if data subjects have enforceable rights in this said country. For the sake of extension, these are just the main obligations, but it will be important to review the full document. We have reviewed the privacy considerations, so let's review now the ethical ones. When we think about possible biases, in our case, our primary source of bias depends mainly on the language we decide to include as risky in training and retraining the model. This may condition our model to predict certain pieces of information as potentially fake simply because of the language being used and it being associated to a certain political group. There are also other considerations when reviewing the ethical considerations for our model. The three goals of ethical AI are accountability, fairness, and transparency. We shall consider the following. Different groups should experience similar levels of positive outcome or rates of errors. In our case, as we just said, certain political groups risk being tagged more as dubious of expressing valid information simply because of the language that they tend to use. So we must pay attention to the specific terms that we highlight as risky of being part of fake news to avoid biasing the models and in order to achieve fairness. To make our model accountable, the users will be offered a direct means of communications if they believe that the output of the model is mistaken, as we have already explained. Since we are responsible for the model's performance, we'll provide a direct means of communications in the web in case the users have any concerns or questions. Finally, we shall provide a clear description of the data usage and model functioning in our web. We'll pay particular attention to clearly describing the feature importance, so we will explain to the user which attributes the model is using and in which ways it's assigning attributes to reach its decisions. Thank you.